So if we added up just the first few, then we can compute the sum, a half, a quarter, an eighth, a 16th. Those were the only guys we added, but then if we added them up, let's see what we got. So ignoring my little doodles in there, when I put the colors down, I filled all but one box. So how many boxes were there? Well, it was 8 by 8, so there were 64 boxes. I filled all but one. So I guess I filled 63 out of the 64 boxes, which is, well, another way to put it is that it was the whole minus one of the boxes, minus 1 over 64. So I guess if we continued, we could see perhaps a pattern. Let's add one more. I'll add one more of these tiny little fractions to both sides. And then this was half as big as that. So 128th minus 1/64 is minus 1 over 128. So it looks like there's some sort of suspicious pattern going on here. If I add up fractions which are obtained by dividing by 2 at each step, then the result is a little less than 1. And we saw it in the picture, right? We were filling up the whole square. That was 1. And as I add up a half, a quarter, an eighth, a 16th, a 32nd, a 64th, and even more, I get something which is just a hair less than 1. So you could keep going. You could just keep going forever, or as far as you like. And so as you go further, you get a sum that's closer to 1, but not equal to 1. And so it might be fun to think about what happens. Let's not actually add, but let's just think about what happens if I continue forever. So I'll just write dot, dot, dot to indicate, let's imagine the sum going on forever. So you could say, well, you know, there's infinitely many terms there, so you couldn't really add it up. So what on earth does that mean? Well, in some sense, it makes mathematical sense. You could say, well, the meaning of my expression here is really, it's a sequence of sums. You know, I add the first so many, and then I add another one, and I add another one, and I look at what's happening to the result. And of course, if I add 1 plus 1 plus 1 plus 1, you know, arbitrarily many times, I get a number that just grows and grows and grows. Well, that's a little bit less interesting than this, because as I add these guys, even though, you know, there's no end to this sequence, the sum is always less than or equal to 1. So as I keep adding these guys up, the fractions add up and stay inside the box. So it turns out that you can make some real mathematical sense out of saying that an infinite sum is actually equal to 1. So here we see our infinity in the box. Since you know, if you had an infinitely sharp pencil, you could draw infinitely many squares and rectangles that, it turns out, actually leave nothing. Every piece of the square eventually ends up in a little square or rectangle if you subdivide far enough. And so that somehow is the meaning of this sum.